Zonal circulation of the atmosphere involves the consideration of the distribution and flow patterns of permanent wind systems in latitudinal zones from equator towards the poles, wherein characteristic features of the air circulation on the Earth's surface as well as at different heights in the troposphere are considered. Such zonal circulation is related to the global pressure and wind belts, which also register seasonal variation. On an average, the location of high and low pressure belts is considered to be stationary on the globe, though they are seldom stationary and continuous. Consequently, winds blow from the high pressure belts to the low pressure belts. The direction of such winds remains more or less the same throughout the year, though their areas change seasonally. Thus, such winds are called the permanent winds. Since these winds are distributed all over the globe and these are related to thermally and dynamically induced pressure belts and rotation of the Earth, and hence they are called the planetary winds. These winds include the trade winds, westerlies and the polar winds. By going through this lesson, you will be able to learn about the planetary winds and their types. It may be mentioned that both surface and upper air circulations are interrelated and control the weather conditions of the Earth's surface at different spatial scales. For example, the tropical zone is dominated by Hadley cell of surface easterly trade, that is the northeast and southeast winds, and upper air anti-radars or westerlies. The mid-latitudinal Ferrel cell is characterized by the surface westerlies associated with cyclones and anticyclones, and the upper air Rossby waves, which are named after Carl Gustav Rossby, having west to east circulation and the jet streams. And the polar cell has the prevalence of surface polar winds, which move from northeast and southeast in the northern and southern hemispheres respectively, and the upper air westerly polar jet streams. Heating of the Earth by the sun is not uniform. The equatorial regions receive much more heat than the poles. The belt of the maximum insolation of the thermal equator moves north-south corresponding to the apparent movement of the sun. Heat is transported from the equator to the poles to achieve heat balance. This is done mainly through atmospheric circulation and to some extent through ocean currents. In the equatorial regions, warm air rises up and moves equatorward. Air streams and ocean waters moving north or south undergo deflection due to the Earth's rotation. The flow turns left or right depending on the direction of the motion, rendering the stream westerly or easterly as the case may be. This is termed the Coriolis force, and the magnitude of the Coriolis deflection is governed by the latitude. The heat transport to establish global heat balance results in a definite pattern of pressure and winds. The zonal circulation of the surface winds is studied in the three zone systems, namely tropical circulation, mid-latitudinal circulation and the polar circulation. It may be mentioned that the belts of permanent or planetary surface winds are approximations, as these wind belts are not continuous and regular in reality because of uneven distribution of the land and sea and their contrasting nature of heating and cooling. The tropical circulation zone of the planetary surface winds extends between equator and 25 degree to 30 degree latitudes in both the hemispheres and very closely corresponds to the Hadley cell of air circulation. The middle portion of this zone is dominated by thermally induced low pressure surrounding the equator and is popularly known as equatorial low pressure belt, while the outer margin of this zone is characterized by dynamically induced due to subsidence or sinking of the air from the above high pressure surrounding the tropics of Cancer and Capricorn, known as subtropical high pressure belt. The air near the equator is heated due to the solar radiation, rises upward, and after reaching the upper troposphere turns to the north in the northern hemisphere and south in the southern hemisphere, gets cooled, becomes heavy and descends near the tropics of Cancer and Capricorn to form high pressure. Thus, the pressure gradient is oriented towards the equator. This results in the circulation of the winds from subtropical high pressure areas to the equatorial low pressure, and thus the equatorial zone becomes the zone of convergence of surface winds and the tropics become the zones of divergence. The convergence zone is characterized by higher amount of solar radiation, more evaporation and relative humidity, cloudy sky and heavy precipitation, while the divergence zone is dominated by highest amount of solar radiation, more sunshine, low or say least evaporation, clear sky, very low relative humidity, least precipitation or almost dry conditions. This circulation zone is characterized by north and blowing trade winds, but their actual direction becomes northeast in the northern hemisphere and southeast in the southern hemisphere due to the Coriolis force and angular momentum and anti-trade winds or the westerlies aloft. It is important to note that this primary tropical circulation of the atmosphere moves heat, energy and moisture from low latitudes to high latitudes. Formerly, it was believed that trade winds blow from the subtropical high pressure belts to the equatorial low pressure belt. The northeast and the southeast trades converge along the equator, and there are upper air anti-trades blowing in the opposite directions of the surface trade winds. The weather conditions throughout the tropical zone remain more or less uniform. There is a belt of calm or doldrums characterized by feeble air circulation. These views of the weather conditions prevailing in the tropics are now considered as old concepts and have now been refuted on the basis of new information based on numerous observations made in the upper air and near the Earth's surface during and after the Second World War. Doldrums. A belt of low pressure, popularly known as equatorial trough of low pressure, extends along the equator within a zone of 5° north and 5° south latitudes. This belt is called the belt of calm or doldrums because of the light and variable. It was believed that doldrums is a regular feature all along the equator and is characterized by convective instability leading to cumulonimbus clouds and copious rainfall daily. But the recent observations have now shown a belt of doldrums is not continuous but is confined to certain localities only. This belt is subjected to seasonal and spatial variations due to northward and southward movement of the overhead sun, summer and winter solstices. In last, the belt of the doldrums shifts northward during the summer solstice, that is when the sun is vertical over the Tropic of Cancer on 21st June and comes back to its normal position at the time of winter solstice when the sun is vertical over the Tropic of Capricorn, which is on 23rd December. According to 𝗏𝗏, the doldrums extend up to 200 longitudes in discontinuous manner. 𝗂𝗽 has identified 3 zones of doldrums, for example, Indo-Pacific doldrums extending from the eastern coast of Africa to 180° longitude for a distance of 16,000 kilometers and covering an area of 25.8 million kilometers square, thus covering about 1/3 of the total length of the equator. Equatorial western coastal region of Africa and western coastal margin of Central America. The next zone, intertropical convergence zone. A few meteorologists and climatologists believe in the existence of cyclonic fronts in the equatorial regions, while some refute this concept on the ground that fronts are formed only when 2 air masses of contrasting temperatures converge, but such conditions are not found in the equatorial region. The equatorial or the tropical fronts are called intertropical fronts or the intertropical convergence. These fronts represent the meeting ground of northeast and southeast trade winds. The northern and southern boundaries of the intertropical convergence are called north intertropical convergence and south intertropical convergence respectively. There is seasonal shifting in the north intertropical convergence and south intertropical convergence with the northward summer solstice and southward migration during the winter solstice of the sun. The next one, equatorial westerlies. On an average, there is westerly air circulation from west to east in the doldrums or say in the intertropical convergence. These westerly winds have been called by 𝗏𝗏 as equatorial westerlies, which cover 200° longitudes. According to 𝗏𝗏, the equatorial westerlies cover the areas extending from the western parts of Africa across the Indian Ocean to the western Pacific Ocean. The equatorial westerlies are associated with strong atmospheric disturbances or the cyclonic storms. He further maintained that southwestern monsoons of South Asia are in fact equatorial westerlies because these winds are extended up to 30 to 35 degree north latitudes over the Indian subcontinent due to northward shifting of the north intertropical convergence at the time of the summer solstice. Trade winds. There is more or less regular inflow of winds from the subtropical high pressure belts to the equatorial low pressure belt. These tropical winds have northeasterly direction in the northern hemisphere while they are southeasterly in the southern hemisphere. These winds are called the trade winds because of the fact that they help the sea merchants in sailing their ships as their direction remains more or less constant and regular. According to Ferrell's law, based on the Coriolis force generated by the rotation of the earth, trade winds are deflected to the right in the northern hemisphere and to the left in the southern hemisphere. There are much variation in the weather conditions in different parts of the trade winds. The poleward part of the trade winds or eastern side of the subtropical anticyclones are dry because of strong subsidence of air currents from above. Because of the dominance of anticyclonic conditions, there is a strong atmospheric stability, strong inversion of temperature and clear sky. On the other hand, the equatorward part of the trade winds are humid because they are characterized by atmospheric instability and much precipitation as the trade winds blowing over the oceans pick up moisture. It may be stated that the trade winds are more regular and constant over the oceans than over the lands. At some places on the lands, for example Southeast Asia and southern United States of America, the trade winds disappear during the summer season due to formation of the low pressure cells because of high temperature, but the trade winds are more constant and regular over the continents during the winter season. It may be pointed out that the zone of trade winds is called Hadley cell on the basis of the convective model prepared by George Hadley for the entire earth. It may be mentioned that all of the planetary surface winds, that is the westerlies and the polar winds, trades are most persistent and regular wind systems. Vertically, trade winds have two layers. For example, the surface layer of the moist and unstable air, and second, the upper layer of the dry and the stable air. The surface layer is characterized by high lapse rate of temperature over the oceans up to the height of 600 meters. The surface trades are also characterized by much convective and turbulent activities over the western parts of the oceans and eastern part of the continents. The equatorward part of the trade winds is more humid than their poleward parts. The vertical depth of the trade winds varies seasonally, but the average depth varies between 1.5 to 3 kilometers. There is anti-trade circulation in the upper troposphere. In other words, in opposition to the northeasterly and southeasterly trade winds on the surface, there are westerly winds aloft in the upper troposphere. Mid-latitude zonal circulation extends between 30 degree to 60 degree latitudes in the northern and southern hemispheres and is represented by subpolar or Ferrell thermally indirect cell of air circulation, wherein winds blow from the subtropical semi-permanent high pressure belt to subpolar thermally indirect semi-permanent low pressure belt in both the hemispheres. The Ferrell cell of atmospheric circulation is not as much effective in the zone as is the Hadley cell in the tropical zone. This general surface air circulation is westerly, which becomes southwesterly and northwesterly in the northern and the southern hemispheres respectively due to Coriolis force. The following are the characteristic features of this zonal atmospheric circulation. The actual wind systems in the mid-latitude zone is quite different from the three-cell model of the atmospheric circulation because the local conditions of the surface and aloft complicate the general circulation pattern. As per three-cell model of the meridional circulation, there should be active meridional low between subtropical high pressure and the subpolar low pressure belts, but the real meridional circulation is weak and is interrupted by frequent high anticyclones and low cyclones pressure systems. The general surface zonal circulation is from west to east, but there are a lot of variations in both directions and velocities. It is interesting to note that unlike Hadley cell, the upper air winds also have westerly component. The surface westerlies are stronger in the southern hemisphere than in the northern hemisphere because of comparatively less friction due to over-dominance of the oceans in the southern hemisphere than in the northern hemisphere where land surface is predominant. The maximum transfer of energy and angular momentum takes place between the latitudes 38° to 40° in both the hemispheres, and hence the westerlies become strongest. It may be mentioned that such an active energy transfer is not accomplished only by weak meridional circulation but also by anticyclonic and cyclonic waves. The poleward part of this zone is in fact a mixing zone of warm tropical and subtropical winds and cold polar winds along the polar fronts. The upper air circulation is also characterized by westerly Rossby waves in the upper troposphere and lower stratosphere. The Rossby waves are meandering loops of flow patterns of upper air westerlies and are embedded with the jet streams. The Rossby waves have westerly component of airflow which is directed from west to east, but due to seasonal shifting, the meandering loops of Rossby waves are intensified and are directed north to south, and hence there begins meridional circulation aloft instead of horizontal flow which is from west to east. This meridional circulation also modifies surface zonal flow, and hence there begins transfer of energy and angular momentum poleward more vigorously. Horse latitudes. The dynamically induced due to the subsidence of the air currents, subtropical high pressure belt extends between 30 to 35° latitudes in both the hemispheres. Thus, this belt separates two wind systems, the trade winds and the westerlies. It is also apparent that the subtropical high pressure belt is the source of origin of the trade winds, blowing towards equatorial low pressure belt, and westerlies blowing towards subpolar low pressure belt, because winds always blow from high pressure to low pressure. The air, after being heated near the equator, ascends, and after blowing in the opposite direction to the surface trade winds, descends in the latitudinal zone of 30 to 35°. Thus, the descent of the winds from the above causes high pressure on the surface, which in turn causes anticyclonic conditions. This is why anticyclonic conditions are causing atmospheric stability, dry conditions and very weak air circulation. Thus, this zone of 30 to 35° is characterized by weak and variable winds and calm. This belt of calm is very popularly known as the horse latitudes because of the fact that in the ancient times the merchants had to throw away some of the horses being carried in the ships in order to lessen the weight so that the ships could be sailed through the calm conditions of these latitudes. Anticyclones are produced due to the subsidence of the air currents in the horse latitudes. These anticyclones are known as subtropical highs or subtropical anticyclones, the eastern and the western parts of which are characterized by contrasting weather conditions. The eastern parts spreading over the western parts of the continents are marked by descent of the air currents, inversion of the temperature and consequent atmospheric stability and dry conditions. This is why hot and dry tropical deserts are found in the western parts of the continents within the latitudinal zones of 20 to 30° in both the hemispheres. For example, Sahara and Kalahari in Africa, Chile and Peru desert or Atacama desert in South America, Arabian and the Thar desert in Asia, deserts of southwest United States of America and the Australian deserts. The western parts of the subtropical anticyclones covering the eastern parts of the continents and western parts of the oceans are humid because of some sort of atmospheric instability which is caused due to weakening of the air descent, for example, in the areas of the Caribbean Sea, Mexican Gulf and the adjoining areas eastern China, southern Japan, southeast Brazil and eastern Australia. Westerlies. The permanent winds blowing from the subtropical high pressure belts, which is between 30 to 35° to the subpolar low pressure belt, which is up to 60 to 65° in both the hemispheres, are called the westerlies. The general direction of the westerlies is southwest to northeast in the northern hemisphere and northwest to southeast in the southern hemisphere. There is much variation in the weather conditions on the poleward paths where there is convergence of the cold and denser polar winds and warm and lighter westerlies. In fact, a cyclonic front called as polar front is formed due to the convergence of two contrasting air masses as referred to above, and thus temperate cyclones are originated. These cyclones move along with the westerlies in the easterly direction. Thus, the general characteristic feature of the westerlies are largely modified due to cyclones and anticyclones associated with them. Because of the dominance of the land in the northern hemisphere, the westerlies become more complex and complicated and become less effective during the summer seasons and more vigorous during the winter season. These westerlies bring much precipitation in the western parts of the continents, for example, northwestern European coast, because they pick up much moisture while passing over the vast stretches of the oceans. The westerlies become more vigorous in the southern hemisphere because of the lack of land and dominance of the oceans. Their velocity increases southward and they become stormy. They are also associated with the boisterous gales. The velocity of the westerlies becomes so great that they are called roaring 40s between the latitudes of 40 to 50 degrees south, furious 50s at 50 degrees south latitude, and shrieking 60s at the 60 degrees south latitude. The upper air circulation in the mid-latitude zone is also westerly and is called the upper air westerlies, which are associated with the westerly Rossby waves embedded within the corridors of the high-speed winds called as the jet streams or the subtropical jet. These subtropical jet streams control Indian monsoon. Due to summer warming of the North Pole areas, the equator-ward pressure gradient is lessened. The surface westerlies are weakened and hence the upper air jet streams shrink and migrate towards the North Pole. But during northern winter, which is the winter solstice, the polar areas are cooled and high pressure is intensified, with the result the equator-ward pressure gradient is steepened, di-surface westerly circulation becomes strong and the jet streams migrate as far south as the Tropic of Cancer and thus affect the Indian monsoon. The surface polar front also migrates southward, with the result cold polar air masses invade the tropical areas and cold waves are generated in those countries where there is absence of east-west mountain barriers. For example, during the winter season, cold powdery polar winds reach as far south as the New Orleans, Galveston and Houston, located near the Mexican Gulf Coast, and lower the temperature to frost level due to absence of any mountain barrier stretching in the east-west direction. On the other hand, the Himalayan ranges protect India from the invasion of the cold polar waves coming from over Siberian Arctic region. Polar circulation is represented by the polar cell of the atmospheric circulation, which on an average is confined between 60 to 90 degree latitudes in both the hemispheres and is characterized by surface polar easterly winds, upper air polar whirl and westerly winds, eastward flowing jet streams, upper air divergence and temperature inversion, surface divergent circulation over polar areas, mainly over the North American and Eurasian cold poles, etc. It may be mentioned that cold pole representing lowest temperature does not coincide with the geographical pole. That is why there are two cold poles in the northern hemisphere as mentioned. Since temperature remains below the freezing point during most part of the year, the high pressure systems and the resultant divergent air flow from polar areas are more persistent and become annual feature. The influence zone of the cold poles expands during the winter season and shrinks during the summer season. The pressure gradient between the polar high pressure and subpolar low pressure generates easterly air circulation known as polar circulation dominated by weak polar easterly winds, which are elaborated. A low pressure belt produced due to the dynamic factor lies within the latitudinal belt of 60 to 65 degrees in both the hemispheres. This belt of low pressure is more persistent in the summer season but generally disappears in the winter season. The Icelandic and the Aleutian low pressure cells persist throughout the year. There is very high pressure over the poles because of exceedingly low pressure. Thus, winds blow from the polar high pressure to the subpolar low pressure cells. These are called as the polar winds, which are northeasterly in the northern hemisphere and southeasterly in the southern hemisphere. The zone of polar winds shrinks due to the northward shifting of the pressure belts at the time of northern summer, which is a summer solstice in the northern hemisphere, but it is extended up to 60° north latitude during the northern winter, which is the winter solstice. As mentioned earlier, polar easterly winds are weak but become stronger and more effective during the northern summer, that is summer season in the northern hemisphere. Tundra region is characterized by weak pressure gradient resulting into weak easterly circulation, which makes Tundra region the least stormy region of the planet Earth. The polar easterly wind system is complicated in the southern hemisphere by the presence of ice-capped continent of Antarctica, where anticyclone circulation is predominant feature mainly in the eastern part of the continent. Planetary winds are so called for they exist throughout the year and almost maintain the same direction. They are essential winds as they play an important role in the development of cyclones, hot deserts, etc.